All right, hey everybody. Working here on a little bit of Sabbath work. Algebra 2, lesson 7-4, graphing the sine and cosine functions, and we've got to work with things like amplitude, the frequency, the midline, the period, and the period of the whole function. So let's get right into it. Here's a summary of the lesson. Up there at the top, we're going to generalize right here. This is A in the front. That's going to have to do right out here with our amplitude. This B is going to adjust and affect the period, and it's going to be the same for sine and cosine. We're going to end up with our frequency being like the B over the 2 pi. So, and then if we're looking at the frequency, that's going to be this B value. It's going to affect it right there. So, now the frequency, how many times does it complete the cycle? So the period, how long does it take to complete the cycle? And again, the frequency, how many cycles happen in our normal 2 pi. So all of this can all kind of go together, but let's jump into it. So last thing down here at the bottom, all of our different transformations that eventually we can do. A stretch, the vertical stretch, the horizontal stretch, left and right transformations, vertical, so phase shifts and the vertical transformation, sliding the whole sinusoidal up and down. And our period could always be calculated by taking 2 pi, the normal period, divided by this B value, the angular frequency or frequency. So let's go here, the periodic function. Hopefully, if we took all of these values here, and we're working with the sine graph, and we took all of those and we plugged them in and graphed them, you would see a graph like this. Let me see if I've got one other animation. No, I don't have that loaded up. So let's just keep going with the lesson the way it is. The period, how long does it take to complete the cycle? So if we take one cycle here, 2 pi is our normal period for sine or cosine. And the fact that it does this cyclical completing cycles over and over, that's going to be referred to as a periodic function. The graph itself, often referred to as a sinusoidal. We got these. See if I can launch. I think this is the one I like the best. I can load this one up for you, and we'll take a look at an animation of that work at work. Let's try that again. Let's just see if we can launch. This one is the one I really like best. So get that one over and let's put it in a new window. All right, let me share the right screen with you. All right, so we've got this unit circle showing that it's traversing around here. Sine, if you remember, opposite of hypotenuse, opposite was always going to be the vertical side, so it's the y value. So let me come down here and let's animate the sine as it goes around here, starting at when it gets back here to always the initial starting location at 0. And let's turn that on. So it's finishing a cycle here. Let's watch as it finishes and it'll come back and start all over from the beginning. So there's my 0. There's my pi over 2, down to pi. It's always doing the y value. See the orange vertical here? That's what it's graphing as it goes around. So here it is creating my sine graph. If you watch that, that's going through 2 periods of the graph, 2 cycles of the graph. All right, so that's just there's my sine animation. So I'll let that run in the background. Let's go back to the problem we were working on. I think it was, that's not it. Right here. All right. So some other pieces that are important for working at. So this little graph here, that animation, and then here, if you calculate it all out, plotted all the points in here, you would start to see that shape of the graph. Then here, if we looked at two other vocabulary words here, the midline, again, and some resources will use a slightly different name here, but midline is most common. This dotted line down the center of the graph. So it's like half the graph goes above it and half below it, sort of thing. And then the amplitude is how high is it above and below? So how far does this go below the midline? 1. And how far above? 1 also. So the amplitude of this graph is 1, and the midline would be at the y=0 line for this graph. If we asked for the period of this graph, how long does it take to complete that cycle again? That's one of our key vocab words here. So that would be 1 cycle of the graph. So 2 pi from 0 to 2. That's the period. Frequency, it completes 1 cycle in that 2 pi on this graph. And let's see, that's the first vocab. Amplitude, again, we just had that. So what's the amplitude here? My midline is right down here on the x-axis. How far does this one go above? 3. There's 2 right here, so 1 more 3. That number out there is always going to be your amplitude. So there's the amplitude of this graph, and then the period for this graph. How long did it take this graph? This is your cosine graph. Your cosine graph is going to have that shape, and like a U or a valley. And if you imagine turning this thing sideways, you could see it sort of has a shape of a C. So the period there was 2 pi for the plane cosine and the plane sine graphs. Both will have that. Just if you come back to the general sine graph, this was our sine graph. If you take that green highlighted and you turn it sideways, hopefully you kind of can use your imagination and say that general shape without any transformations is more like an S. And again, with the cosine, if you don't have any transformations moving it around and you're trying to figure out where to start it, it's just going to be that valley U, or if you turn it sideways, a C. All right, part B here. Well, what happens with the negative out in front? We've worked with that all year round. So hopefully you remember that that was going to end up taking our original sine graph. Remember the sine graph that we just looked at? It had this general shape. And if we put a negative, that's going to flip it. So then it's going to start by going down, back up, and then down. So it had the reflection. The 2 means we've got to complete 2 cycles of the graph where we would have normally completed 1. So we've got to, if we start here, finish already. So halfway through, we got to be at that low point. And then up here, we're halfway over here, this high point, and right in between, we're going to have to cross the midline. So we would complete 1 cycle there and 2 cycles. And that's what it's showing right over here. So we would have our first cycle finished. And then after that, we would have the second cycle finished, the frequency, 2 cycles of the graph where we normally up to 2 pi, like when we looked at the last one without that frequency value in front of the X. Our normal period, how long it took to finish the cycle, was 2 pi. All right, so that's a lot of stuff already in one lesson, perhaps even enough. So this next one, my frequency is a half. I have to just do half of a cycle Let's see, and we're talking about sine, so reminder on sine. That was the one that had that general shape. Let's see if I can get it a little more. Up 1, down 1, started at 0. And we've completed just half of a cycle in our normal period of 2 pi. And again, why am I saying that? Because this frequency right here, half, tells me how much of the graph to finish in that amount of time. Continuing then, so 5, my amplitude, that's how high it goes above and below the midline, that blue dotted line I just put in. And let's see, we were asked for the period, to calculate the period here. I don't think it asked that, did it? No. But I would take my normal period, 2 pi, and divide it by the frequency of a half, which that's 2 pi times the reciprocal of a half. Because remember, fractions like a division problem, 2 pi divided by the 1/2 is another way. And so flip this and change it to multiplication or reciprocal, and then that's 4 pi. And if we look at it, we should see that it finishes the full cycle or period of the graph, which would be to there at 4 pi. So that's just a little extra period calculable at whatever point. Part B on here asked you to calculate the average rate of change throughout this whole thing. So I just did this in advance because, so if we were going to do what's the average rate of change here from 0 to this is pi. So that's this one that I've got right here. And my coordinates there at the 0, 0 up to the top piece up here is pi 5. So 5 minus 0 in the numerator, that's my y values, and subtract. Remember, average rate of change is like slope, but technically because this has curves, slope is on linear equations, and this really isn't a line. So it's kind of a technicality. We're just doing the same calculations as slope, though. If we wanted to look at a different piece of the graph, for example, let's say we're going to look from pi to 3 pi. So here's my pi. That would be this point up here all the way over to the 3 pi down here. So that was this blue dotted line they had on there. So my y values there, the -5 and the 5, subtracted, vertical change over the 3 pi minus the pi. And you can see the calculations there, -10 for -5 minus 5 and 3 pi minus 2 pi, and simplify -10 over 2 pi, dividing the numerator and the denominator by 2. And then I just did one more at the very end, and you know, you could do a rate of change between one of these horizontals, but that's going to be 0 between those two or these first and last ones. But this last one, the y 0, our y here is 0, our y there is -5, that's right here. We're subtracting to do rate of change or slope. And then the x's here, 4 pi minus this 3 pi right there. And we end up with the 5 over pi. So how does the average rate of change differ within one period? You just see the different ones. If you're on the horizontal, obviously they're all rate of change of 0, but you've got these 5 over pi's or -5 over pi's, depending on if your line is sloping in the positive direction or a negative direction. So because of the amplitude and those steepnesses of those high and low points and midpoints are going to be similar. All right, then if we go on here to example 4, this clock problem, we've got a clock. The hour hand here is 5 inches. The hour hand, 5 inches. And then they want to know the keeping track of the hours and the inches of that. So if we graph that, we're 5 inches out here at time 0, which I think it says to use as midnight. That midnight represents 0. So this point up here is for midnight. We're straight up here at 5 inches away. And then as the hours go around and up till noon, at noon, wouldn't the hour hand end up back? If this is midnight, that hour hand is on the 12, and at noon, wouldn't it be back on the 12? So if we went 12 hours later, midnight to 12 p.m., that would give us this cycle of the graph, because as that hand moves, the distance it is away from that is the height of it is going to go up and then down and then negative. So we're going to be up here. It's getting lower. It's just traveling around the same thing as our unit circle as it goes. And because as it goes, the distance varies, you're going to get this shape of your graph. So writing the equation for that, well, what's your amplitude? How far from the midline do you go up or down? 5. And it is the cosine graph because it's starting from the y-axis and it's a valley, so the cosine. And then for my frequency, again, you're going to, period was our normal 2 pi over the frequency. And we're trying to figure out what is this frequency right now. So if you take your period of the graph over your frequency, you should get what we need for that b value. So, or 2 pi over the frequency. So my period here is the 12. So if I took 2 pi over the 12, how long it takes, I'm going to get my pi over 6 times that x. And it hasn't been moved left or right at all. It hasn't moved up or down at all, so I don't need any plus or minus on the x. And I don't need any vertical transformation on the outside out here either. So our final equation for that graph, for the hour hand and how far it moves and the points as you calculate those, should be 5 times the cosine. You could do pi over 6x. I like it like that. Somebody might write it as x over 6 times pi in this spot, but variations, but they would represent the same thing. And one more. So if they give us 2 different representations, then we're supposed to compare them. So the function notation, and we're supposed to compare the period and the amplitude. So amplitude's pretty easy. How does the 4 amplitude here compare to the amplitude of 4 over here? That's pretty straightforward. They're both 4. Only thing on this one that I might say is normally, if you remember, our sine graph starts at 0 and goes down and then up. This one's been flipped, so it'd really be a negative 4 sine. And then to find, again, that frequency out here, 2 pi over the period is going to equal that b value. And what's my period here to complete one cycle of this graph? 4. So 2 pi over 4 would give you the pi over 2. Pi over 2 on there ends up being the frequency for completing one cycle of that graph. And so when you look at that, it asks how do the amplitudes, the period. So this period was 4, and then over here, 2 pi divided by the pi over 4, the frequency on this one. So 2 pi. Over here, we know that the period for this graph, that's what they asked us to compare, was 4. How long it took to complete that cycle. Over on this one, my 2 pi divided by my pi over 4, or multiplied by the reciprocal, 4 over pi. And there the pi's are going to divide each other out or simplify, cancel, reduce. So my period over here is going to be 8. So this one is twice. This one is twice as long, the period, as the other one. So if you have those and you kind of understand the period, how tall and low, the frequency, how many cycles of the graph are completed in our normal 2 pi period for sine and cosine. With the frequency can always be calculated doing that. Yeah, and that's our frequency, that's our period, that's our amplitude type of information on the sine and cosine graph.